Welcome to Super Easy Physics and Mathematics. Today we are starting the series on looking at the questions that proved quite challenging to the candidates that wrote the paper 2 extended February-March 2021. There are 40 questions in this particular paper 2, but we are concentrating on those questions that most of the candidates fail, the question that most of the students did not get correctly. So let's look at them, and then we are going to look at the reason why most students failed it, so that as you are preparing for the exam you can avoid such mistakes. The first paper question on this paper that proved quite challenging for the candidate that wrote this exam is question 2. A ball hit a bat with a velocity of 30 meters per second and leave the bat traveling with a velocity of 20 meters per second in the opposite direction. The ball is in contact with the bat for 0.1 second. So this is a momentum question. What is the magnitude of the acceleration of the ball while it is in contact with the bat? So let's assume that this is the bat. Then for us to get the acceleration, so let's see, this ball went and had contact with the bat, and then the ball was reversed with this speed. So we have the initial speed and the final speed. So the initial speed was 30 meters per second due east. I just had to put, and let's assume the direction due east is positive. Then coming back is negative 20. Then the acceleration is equal to the final velocity, the difference between the final velocity and the initial velocity divided by the time. So that gives negative 50 meters per second square. So most students failed this question because they did not put into consideration that acceleration, the velocity have direction, is a vector quantity, and then you have to put the direction into play. So most students did not put this direction into place. That is why they failed it. So many candidates failed this because they did not recognize the vector nature of velocity. So take note when you come across this question next time, so you put that into consideration. The next question is question 7. An object moves in a circular path with a constant speed as shown. So the object is at position P and is moving at this position P. The linear velocity points in the direction of Y. Then the centrifugal force points in the direction of X, and the centripetal force points in the direction of Z. Which statement about the acceleration of the object when it's at P is correct? He said the acceleration is in the direction of arrow X. So most students actually did not pick this option. They easily eliminated this option out. Then this is the direction of the centrifugal force, so that is not the correct answer. It is then where student had issue was the acceleration is in the direction of Y and the acceleration is in the direction of Z. So most students had issue with these two options. So this is where most students picked. But let's see which of them is correct. The actual acceleration of the object points in the direction of the centripetal force, which is to the center of the circular path. So let's see the reason. Almost all the students did not pick the centrifugal direction. Now, the fact that the force on the rotating object is towards the center of the circle was often not recognized. Let's go to the next question. Question 10. A horizontal force pulls a bus along a horizontal surface. The bus gains 30 joules of kinetic energy and 10 joules of thermal energy is produced by the friction between the bus and the surface. How much work is done by the force? Now, the total work done by the force is equal to the kinetic energy plus the work done by moving the object along the path. So, total work done is equal to the 30 joule kinetic energy plus the thermal energy, which is 10 joule to give you 40 joule. Now, kinetic energy plus thermal energy dissipated. So, now this is the reason why most students fail this question. Some students interpreted the question as if it is asking for the useful work done. Now, if you are talking about the useful work done, you are talking about the kinetic energy, which is the 30 joule. And then most students ignore the thermal energy that is as a result of the frictional force between the horizontal surface and the pulling of the horizontal bus. So, the work done is giving, that is, the work done is giving the object kinetic energy. So the question was not asking for the useful work done, it's asking for the total work done. So that is why most students failed it. So most students took this question option C, which is wrong, but the actual answer is option D. So let's go to the next question. The next question is question 17. A piece of melting ice at 0 degrees Celsius and a beaker of boiling water are both in the laboratory. Now, the laboratory is at 20 degrees Celsius. What is happening to the temperature of the melting ice and what is happening to the temperature of the boiling water? So you have the water boiling here, and then you have the ice melting on the table beside the water, and then the temperature of the lab is 20 degrees Celsius. Now, what is happening? So let's just look at now. Most students took different options actually. So we have to have the idea that at melting point and at boiling point, the temperature of the ice remains constant while it's melting, while the ice is changing from solid to liquid, while the temperature of the liquid remains constant. When water boils, that is converted from liquid to gas, the temperature, the boiling point is constant. So the actual answer for this question is A. So we have to realize it as ice is melting and as water is boiling, the melting point remains constant and then the temperature remains constant while water is boiling at the boiling point. So many students fail to recognize that temperature is constant at melting point and boiling point. What is the approximate wavelength in air of the highest frequency sound that can be heard by a normal healthy person. So let's see how we got that. So we have that the frequency, the wavelength is equal to velocity of the sound divided by the frequency. But you know that the frequency range that the human ear can detect is from 20 Hz to 20,000 Hz. So the question is, what is the highest frequency sound? What is the wavelength of the highest frequency sound? So we are interested in the highest frequency sound. So the highest frequency sound that the human ear can detect is 20,000 Hz. So use it to divide the speed of sound. So many students did not recognize that the wavelength was being asked for and not the more usual frequency. So most students end up calculating for the frequency. So the next question that the student failed is question 34. A student designed a circuit to use as a dimmer switch for a lamp. So this lamp. Now what happened to the brightness of the lamp and the potential difference across the lamp when the slider moved from X to Y? Now let's see why most students fail this question, because many students did not understand how potential divider works. That is actually the reason. And so because of that, almost all of them took the various options. So option A, B, C, and D. So majority of the students, so almost all the candidates. So the answer that they pick was all the options were among the option that student picked. But if you look at the principle of the potential divider, option B, option C, and option D are wrong. So let's see how the potential divider works. When the slider is moved from point X to Y, so what happens? As we are moving it from X to Y, the potential difference across the lamp will decrease, and then the current that will flow through the lamp also decrease. And when current decreases, what is going to happen to brightness of the light? The brightness of the light also decreases. So what happened to the brightness of the lamp? It decreased. What happened to the potential difference? Also decreased. So the correct answer is A. Let's go to the next question. Question 36. The diagram shows an electromagnet near a coil of wire connected to a voltmeter. The reading on the voltmeter is 0. The switch is closed on the electromagnet. Quickly, what happened to the reading on the voltmeter? Now, many students did not understand that induction of an EMF occurs when electromagnetic field is actually undergoing a variation or is changing. So let's look at that. Once you close a switch here rapidly, an EMF will be induced into this coil here, and then the induction of the EMF will make currents to flow through this magnet. So you see that what happened to the reading of the voltmeter? It keep increasing? No. It quickly increase and stay at maximum? No. It stay at 0? No. What happened? It quickly increases and then decreases. So you're going to see that the voltmeter is going to deflect and return back to 0. So the actual answer is C. So we've come. I know that you are a brilliant student who want to succeed. That's why we are previewing this video. More tutorial solving past questions to assist you will be uploaded on this channel, so please subscribe to keep up to date. Please kindly like and comment on the video, and feel free to ask any question. I will reply you as I go through them. Thank you for watching. So we'll be looking at the